Hello everyone. Today we are going to explore an exciting branch of computer science called soft computing. Think of it as the flexible thinking part of artificial intelligence. Unlike traditional computing, which demands clear cut answers, soft computing allows for uncertainty and approximation, just like how we humans make decisions every day. Instead of asking machines to be perfect, we teach them to make the best decisions with imperfect information. Soft computing was defined by Lofty in 1992. It is defined as soft computing is an emerging approach to computing which parallels the remarkable ability of the human mind to reason and learn in an environment of uncertainty and imprecision. Soft computing consists of several computing methodologies that those are fuzzy systems, neural networks and genetic algorithms. Fuzzy sets is nothing but knowledge representation by a fuzzy if then rules. When it comes to neural networks, it is for learning and adaptations. Genetic algorithms are for evolutionary computation. These form the core of soft computing. Now, let's talk about the first computer methodology of soft computing, that is neural networks. These are computer models inspired by the human brain. Just like a brain learns from experience, neural network learns from data. You can show it many examples like photos of cats, and eventually it learns to recognize a cat even in a new image. There are two types of neural networks, that is artificial neural network and biological neural network. A neural network that processes a single element is known as a unit. The components of the unit are input, weight, processing element and output. These neural systems are very similar to a human neural system. Main advantage is that they solve the problems in parallel. Artificial neural networks use electrical signals to communicate. But the main disadvantage is that they are not fault tolerant. That is, if any of the new artificial neurons get damaged, it will not function anymore. The example is seen in the next slide. Example of neural network: a handwritten character, where a character is written in Hindi by many people. They may write the same character but in different form, as shown in the picture. Whichever way they write, we can understand the character because one already knows how the character looks like. Applications of neural networks. Neural networks is used in signature analysis. It is as a mechanism for comparing signatures made in the bank with those stored. This is one of the first large-scale applications of neural networks in the USA and is also one of the first to use a neural network chip. It has also been used in monitoring. Networks have been used to monitor the state of aircraft engines. By monitoring vibration levels and sounds, early warning of engine problems can be given. British Rail have also been testing a similar application monitoring diesel engines. Another application of neural network is pen PCs. PCs where one can write on a tablet and the writing will be recognized and translated into ASCII text. Next is speech and vision recognition systems. Not new, but neural networks are becoming increasing part of such systems. They are used as a system component in conjunction with traditional computers. Next up we have is the fuzzy logic. Fuzzy logic is another key tool in soft computing. While Boolean logic says yes or no, fuzzy logic says well, maybe. It works with degree of truth. The term fuzzy refers to things that are not clear or are vague. In real world, many times we encounter a situation when we can't determine whether the state is true or false. There, fuzzy logic provides very valuable flexibility for reasoning. Fuzzy logic is based on the idea that in many cases, concept of truth or false is too restrictive and there are many shades of gray in between. It allows partial truths where a statement can be partially true or false rather than fully true or false. It has a wide range of applications such as control systems, image processing, and in medical diagnosis, etc. As you can see in the picture, it is an example of fuzzy logic where a normal question, is it cold, is asked. In Boolean logic, the answer could either be yes or a no with the value 0 or 1. But this is not the case in fuzzy logic. When the same question is been asked, the answers could be very much, little or very less depending on the points. Another example of fuzzy logic is when a robot is there. It wants to move from one place to another within a short time, where there are many obstacles on the way. Now the question arises is how can the robot calculate its movement to reach the destination point without colliding to any obstacle? These types of problems have uncertainty which can be solved using fuzzy logic. Comes the applications of fuzzy logic. Fuzzy logic application is fuzzy control, which is controlling the neuro fuzzy system, intelligent control, and the hybrid control. Fuzzy logic is also used in the fuzzy pattern recognition and also in fuzzy modeling. Another application of fuzzy logic is it is used in ride smoothness control, camcorder autofocus and jiggle control, braking systems, copier quality control, rice cooker temperature control, high performance drives, and air conditioning systems. Next we have is genetic algorithms. These are inspired by natures, especially by evolution and natural selection. Imagine you're trying to find the best recipe for a cake. You try one version, change a few ingredients, test again, keep the best one. That's what a genetic algorithm does. It starts with many possible solutions, selects the best one, mixes them and gradually improves. The genetic algorithm was introduced by Professor John Holland in 1965. It is used to solve problems based on principles of natural selection that come under evolutionary algorithms. It follows biological processes like genetics and evolution. The genetic algorithm can solve the problems which cannot be solved in real time, also known as the NP-hard problem. The complicated problems which cannot be solved mathematically can be easily solved by applying genetic algorithms. A simple way of understanding this algorithm is by considering the following example of a person who wants to invest some money in the bank. We know there are different banks available with different schemes and policies. It's individual interest how much amount to be invested in the bank so that he can get maximum profit. These are the certain criteria for the person, that is how he can invest and how can he get profited by investing in the bank. These criteria can be overcome by the evolutionary computing algorithm like genetic computing. So we have is the applications of genetic algorithms. Genetic algorithm was first used for job shop scheduling in 1994. Another is for manufacturing the cell design in 1996, and next is the fixture design in 1998. It has been used for several scheduling problems, traveling salesmen's problems, and energy optimizations. So to recap, we have covered three powerful soft computing techniques. Those are neural networks for learning like the brain, fuzzy logic for dealing with uncertainty and partial truths, and genetic algorithms for problem solving through evolution. All of these methods help machines make better, smarter decisions, especially in complex real-world situations where traditional computing just doesn't cut it. Soft computing is helping shape the future of AI, robotics, healthcare, finance, and so much more. Thank you for your time, and please like, comment, share, and subscribe to this channel.